ladies and gentlemen, Ruth John.
Thank you, Bruce. Hi, everybody. Good morning. My name's Ruth. Has anybody picked up the printed version of the program this morning? Ruth John, web technologist. Thomas is a member of the Node.js tracing working group. I don't know who Thomas is, but he sounds quite cool, right? He's a full-time open source developer at Upbeat. That's cool. He enjoys working on mad science projects. I want to meet Thomas. If anybody knows who Thomas is, you do?
I met him last week at Node Interactive.
No, yes. This is amazing. Please, I really do want to. Mad science projects? I'm really into this. Thank you. I thought that he might actually be a real person that existed. Good, great. That's not me. I'm Ruth. You can find me all over the internet at Rumira. That's my Twitter handle, CodePen, GitHub, anywhere that you might want to find me. Today, I'm going to talk to you about MIDI. It's a bit of an off-piste subject for a web conference, I know. There's a few reasons why, but to start with, let's address a common misconception about MIDI. And, just noticed my sound's not plugged in, but I'm pretty sure the sound guys have actually got, yeah, we've got the speakers on. This is the common misconception. Oh, that's a bit fuzzy. Right? This is a real website, by the way. This is a real modern website. It's online today. How amazing is that? CameronsWorld.net. But the noises that you just heard, that is not MIDI. That is digital audio. There is a reason that you would think it was. It was probably made on a piece of software that's MIDI enabled, but the sounds themselves, those bleepy sounds, that's just digital audio. MIDI itself is just a data protocol. The reason that we think that MIDI is those bleeping sounds is, of course, MIDI stands for Musical Instrument Digital Interface. And so it came around because of musical instruments, and we kind of get hung up on the musical instrument part of it because it's musical instruments that carry this data protocol. But today I want to talk about the digital interface part because that's the most interesting part. The original specifications came around in the 80s. And they came around because there was a rise of popularity of digital and electronic instruments in the 70s. They'd been invented in the 50s, but they really gained popularity in the 70s. And so they were bringing all these extraordinary electronic instruments into recording studios. And everybody was sitting around thinking, how are we going to get all these instruments to talk to each other? So a group of industry experts, musical instrument manufacturers, all got together, and they formed the MIDI Manufacturers Association, and they brought the first MIDI specification out in 1983. So the first specification was General MIDI 1, and it was formed of 3 parts. You had the actual specification part, so this is the digital protocol where the instruments could actually talk to each other. There was a file format as well, so this is the data held within a file format, so you could share this data around some file formats. Today, it's around, but it's usually part of another file format. So if you're using a big piece of software which has MIDI as part of it, and you're exporting that to use on another computer with the same software, that data will be part of that specific software's file format. And there was also a connector specification, because obviously you had to connect these musical instruments up with each other. And at the time, it was a big fat round connector called a DIN connector. And I'm sure some of you have seen it. You get the MIDI in and the MIDI outs on the back of the old sound cards. And it's big and it's fat and it's got sort of 5 pins. Today, there's a lot of MIDI specifications, and I'm going to talk to you about some of them, because an industry that brings out specifications is a very interesting industry to look at. You can find all the specifications on the MIDI.org website, so if I talk about something too briefly and you want to go and find out more, go and have a look. You can read all about them. There's some really, really interesting ones. The core of MIDI is data, and I can't stress this strongly enough. I've done this talk a number of times, and people will still come up to me afterwards and talk to me about MIDI as sound, and I'm like, yes, it's very related, and we'll talk about that in a minute, but really it's just data. The easiest way for me, the data, order, the crux is messages. So you've got 2 types of messages. There's channel messages and there's system messages. And we can talk more in depth about these messages because the specification is very, very detailed. But The channel messages, just as an overview, that's system-specific messages. So if you've got like a musical keyboard and you're playing keys on that musical keyboard, the channel messages are, I am this key and I am being played at this volume. The system messages are, I am a keyboard and I want to talk to this other musical instrument. The easiest way for me to sort of teach you about this is for me to show you. So I have a URL which I'd all like you to go to so that you can interact with this talk. This is an interactive demonstration. I can see people getting their laptops out. If you have a laptop or a phone or anything like that, this is the URL that I'd like you to go to. Some people are like, come on. It'll be fun. I can spell it out for you. Does anybody need that, or can we all see it? It's goo.gl/H, little v, 8, little u, little p. Now you're going to see, when you land on it, you're going to see a sort of list of, you're going to see sort of 3 buttons. We're going to click on the top button. Don't get overexcited and click on any of the others for the minute. So the pink button. And you should see a keyboard. And when you play the keyboard, we should be able to see the data being played on the keyboard. So this, I'll go back and I'll keep the URL there because I think some people are still going to it. If you get there and you're playing the keyboard and you can see the data, give me like a little nod or something so that, yeah. Okay, we've got some thumbs up. Great. Cool. Like I said, you should see something like this. This is exactly what you would get if you plug in a musical instrument keyboard into your computer and you run the Web MIDI API. This is an API that's available in Chrome as it stands, as is now. And it's relatively simple. And it's actually relatively easy to learn. There's not a great deal of functionality behind it. It's very, very low level. All you do is request MIDI access on the navigator object. All I'm doing here with this bit of code is just looping over the inputs that I'm receiving, just those events that I'm receiving, and then piping them out. And that's just the data that we're getting. There's a few more other bits of functionality, so that you can do things like see all the MIDI instruments that you have connected to your computer. There's a sysx flag there that you can see. It says sysx false. If you set that to true, you can actually send messages back to the instruments if they're capable of doing it. That, my friends, is the Web MIDI API. It's a very, very interesting one. Because it's kind of low level and you're only getting data, it opens up a whole world of hardware to us. There's a lot of hardware out there that's MIDI enabled. What does this data mean? So for a keyboard, we've got 3 values there, all in an array. The first one is a note on value, so we're pressing a note on in a certain channel. The second is the note we're actually playing. If any of you know about music, you'll know that notes run from like A to G. So 60 is actually C in hex, so that's the note C that we're playing. And the last value is the velocity. So this happens on a keyboard. The harder you press, the higher that value will be. And again, we have a note off. So when you release the key, you get the same sort of values, but the first one has changed because it's a note off value. And that's all it is. I want to illustrate data to you just one more time, just so we're all aware. You can do some really fun things with these numbers. With 3 values of numbers, you can just number crunch them for a little bit. We've got code. I just ran them through a bit of a function. There's a text encoder API, which I like, which means actually you can play emoji, which I think is great fun. And you could usually do this with my actual keyboard. If you plug a keyboard, if you've got one, if you plug one into your computer, these demos actually work with a computer, and they're all online. So you can actually plug a keyboard in and actually play emoji, which I think is just, that was one of my favorite demos. But like I said, it's just data. There's no sound there. Support, like I said, is Chrome. Support in Opera as well. I think if we use it more and get more interested in it, the other browser vendors will actually begin to implement it, because I think it's a great API. So what about sound? Like, it is a musical instrument interface. So all the hardware are musical instruments. So we do have to think about sound when we do think about MIDI. And its companion really is the Web Audio API. So what you would do with the data is you'd take this MIDI data, you take these numbers that we have, and you'd play or you'd change the sounds based on the data that we're getting. So you'd need to create some sounds. We'd need the Web Audio API for this. The MIDI API is not going to give it to us. There's 4 main ways that we can create audio with the Audio API. We can create an oscillator. So this is creating a sound wave. We can grab it from the DOM itself. So if we've got an audio element or a video element, we can grab the sound from that using the audio API. We can take it from a stream source. So we can take it from the microphone on your device or the camera from your device, and we can stream the audio from that. Or we can take it from files. So we can actually just load sound files into the audio API, and we can load them into the buffer. One great way of using it with MIDI is to use the oscillator. And to use that, basically, you're just creating a plain sound wave. So you need to create a few parameters, mostly frequency, which is the note that I'm playing. This is a magic function, so you can take the note from the MIDI data, so that's 60 that we had earlier. You can run it through this magic function, and it will sort of spit out the frequency of the oscillator that you want to create with the audio API. There's a lovely bit of code that my friend Dave wrote, which is on CodePen. This is one of my MIDI controllers that I have at the bottom here. And I'm just running the CodePen that he's got and playing my MIDI controller. There was a couple of things that I wanted to illustrate there. You noticed that when I was pressing harder on the pads, it was louder. The pads are velocity sensitive, so the harder you press, you get a higher value, and you can also pass that into the data that you have. And the dials, I was just using just using the audio API and some of the wonderful features that you get with it to distort the sound as well. Recording is important in music. Everybody piles into recording studios, and they've all got these instruments. MIDI needed a way for all these instruments to talk to all the recording desks and all the sound desks that they had. So they brought a specification out for this. This is the MIDI machine control specification. It was a new specification just for that. Funny enough, we actually have a new API for that as well on the web. We have a media recorder API now. This is a new one, came out this year, landed in Chrome and Firefox. It's relatively simple to use. It's a really, really fun one if you have a chance to play with it. You just call new media recorder and then pipe in a stream. So this is the same stream that we were talking about earlier with the audio API. You just take your camera or your microphone and you can stream it in and you can record it and you can do some really, really fun things with it. I don't have a demo for this, but on the Mozilla Hacks blog, Soledad works for Mozilla. She's done a really, really good blog about it. So if you want to read some more and play with it, she's recording some video onto Canvas and then putting some effects on it. It's really, really good. I highly recommend it. Like I said, support is Chrome and Firefox. Bruce is actually finding out now whether Opera is supporting it, which it should do, but when I last looked, they hadn't. So specifications are great, but I've been talking a lot about instruments. And I know that there's going to be some of you in the audience that know a lot about instruments and probably a lot about MIDI, and probably more than me. But some of you probably don't really understand the difference between what I just showed you in that video as a MIDI controller and then the musical keyboard's an instrument. This is a musical instrument. Right? This is a musical keyboard. It's MIDI-enabled. It's actually cheaper for you to buy a MIDI-enabled keyboard than it is for you to not, because the box that pipes that data is so cheap, and they just put it in everything now. So this is one of your most common MIDI instruments. It has onboard audio. That's what makes it an instrument. That means you can play it standalone. You've also got things like electronic drum kits. There's a lot of electronic instruments out there. So the range goes through. You can get like wind instruments and everything. So again, you can play this standalone. You can play it just like a drum kit, and it has noises on it. But you can also plug it into your computer, and it will send you MIDI data. That's quite fun. But again, they're more expensive because they're more instrument types. They have onboard audio. This is a launch pad. This is probably something you would probably come across more as a developer, and maybe some of you actually have. This is a controller. This doesn't have any onboard audio. This is just an array of buttons. And what you do when you plug it into your computers is just sending MIDI data. Specifically, this is supposed to be more of a step sequencer sort of thing, but I'll move on to that in a minute so you can understand that a bit better. Other MIDI controllers, other affordable MIDI controllers are things like this. The top one is an ACE. This is the one that you saw in my video. I have one of these. It just comprises of 8 sort of pressure-sensitive pads and 8 dials. The bottom one's a Korg Nano pad. It's just 16 pads. It's got like a little nice touchscreen on the left as well. They run at about £30, so that's probably about €35 at the moment. They're affordable hardware, which is really, really interesting. And now the web is getting hardware ready, I think that's an important point to make. Just so you know the range of different MIDI controllers that you can get, this is another one. This is an Icon IDJ. Again, there's no onboard audio. The idea behind this is you actually pipe 2 different tracks to either side, and you can mix those 2 tracks. But at the end of the day, it's just a MIDI controller, so you can just plug it in and send data to your browser from it. I actually use this to mix visuals. I don't use it for audio at all. Affordable hardware. There's a lot of hardware that we can code with web technologies now. We've got things like Espruino and Tessel boards, which you can code, like controller boards that you can code with JavaScript. And that's really, really good fun. But when it comes to actually building something, there's a lot of onboarding with soldering and trying to get other pieces of hardware, which, like I said, can be fun. But if you just want to plug and go and just sort of have something that enables something fun that you want to build, or a web app or something, it could be interesting to look at the sort of MIDI controllers that you can get, because they are affordable and it's really, really easy. You just plug them in. These are synthesizers. They're kind of a family of electronic instruments all to themselves. And there's not just synthesizers there. There's drum machines, there's sequencers. I could do a whole talk just on these things. It's probably easier for me to show you again, but I will in a sec. They're more expensive. They will still pipe out MIDI, but they also have onboard audio, and you can play them like instruments. A step sequencer, for instance, it was a bit like the launchpad you saw. You'd have a grid of buttons, and each row would be a different instrument, and you can press the lights for when you want that instrument to play. We can do this. If you still have your link, if you go back to the buttons before and press on the blue button, you will get a row of my step sequencer. I'm kind of thinking that some people have kind of figured this out. Right, this is all you guys joining my step sequencer. I'm just going to turn this down a bit. And when you light up your squares for your row, your noise is going to play from my machine. This is a crowdsourced step sequencer, only available on the web, obviously. It's quite a lot of you. Oh, I think that's the best that's worked. It's kind of funny because there's so many people there that we're just getting every single sound on every single beat. All right, I think we're good. I think well done, everybody. I think I deserve a round of applause. Well done for making music. It looks pretty, if nothing else. So the people have got to the next one already. So, interestingly enough, that was using a lot of the audio API to create those sounds, or buffer those sounds, they're sound files. And a lot of timing was needed so that we could actually play the sounds at the right time when the beat was going through the sequencer, right? This is actually quite difficult on the web, but I'll get to that. There's a MIDI clock. An overriding MIDI clock, which overrides all the specifications. And timing is really, really important with music. Not just when you're playing music and trying to keep in time, say you're in a band with your bandmates, but also when you're recording and playing and stopping and pausing. All of that has to stay in sync. When we're doing things with the MIDI and the audio API, that's all held within the system, and there's a lot of stuff within those APIs to keep the timing in sync. The sequencer I was just using, I was actually using a library on top of the audio API, which is not my usual way of building things, but tone.js is what I used. And I recommend it if you do want to do some really, really fun things with the audio API. It deals with a lot of the timing stuff for you. It deals with a lot, like the step sequencer thing that I was doing. It's got some really, really nice methods behind that. Interestingly enough, timing I'm hoping is going to become bigger on the web. There's this timing object model draft sitting in the WC3 right now. And if you're not interested in music or sound or anything that I'm talking about right now at all, please go and read this draft because it's really interesting. It's all about synchronization of multi-devices. So this doesn't just take into account the audio and the MIDI stuff. This is the WebSocket stuff that we were just doing so that we could literally create a band with all your devices and they could all be synced together. It's also about other media things like animation and the whole sort of realm of it. It's about creating a timing model within your application, and that's sitting there so that you can sync with all the devices and get rid of that sort of latency issue that you'd normally have over the web. So if I start something here and somebody else starts something over there, because we have the latency issue, like matching up that timing would be really, really hard. It's a really, really interesting read. It's sitting at webtiming.github.io/timingobject, and I recommend that you go and read it. We touched a little bit on connectors at the top of the talk. And originally, we sort of had this 5-pin DIN cable connector was the MIDI transport specification. It was a big fat round thing, and it's still around today, and some old MIDI instruments still have it. Today, we have USB. And it's much more affordable, and it's better, and we don't need one piece of data to go in and one piece of data to come out. It can all go through one cable. This is how these things have become a lot more affordable, and we now just have boxes which cost €35. There's also a Bluetooth MIDI specification. So MIDI's kept on top of the technology really, really well. There's a Bluetooth BLE specification. This is Bluetooth being encoded and decoded over Bluetooth low energy, which is especially special. This is my handbag MIDI controller. I have this with me today, just because I can fit it in my handbag. This is one of my favorites, maybe one. This actually works over Bluetooth. So I can just hook this up by Bluetooth to my machine, and just like I was doing, and I can show anybody who's interested later, just like I was doing with the MIDI data before, if I press this, this comes up in the browser under the MIDI API, like all other MIDI controllers. What's interesting, though, is we've got something like that. We've also got a Web Bluetooth API. So this is getting a lot of interest at the moment. I know that Google are putting a lot of force behind it. It's a tricky API to get your head around. It's currently under a flag in Chrome. There's a lot of information around Bluetooth. So this is all to do with the sort of low-energy Bluetooth devices that you have. So it could be the sort of a Fitbit or other sort of device that you'd have around your wrist or something like that, which tracks things like heart rate or steps. All those things are information that you would read and write with the Bluetooth API. And they all fall under this idea of GATT services. Funnily enough, we don't have a GATT service for MIDI data. You'd probably have to write one of your own. But it's still an interesting API to go and have a look at. Again, it's just under the Navigator object at the moment. They're doing a lot of work on it. So you can go and read about it. It might change, but it's definitely worth going to look at. I mean, we've got things like beacons coming out, and that all works with Bluetooth Web. And like I said, the web is getting hardware ready. It's very interesting. So we talked a lot about sound, we talked a little bit about hardware, but what about beyond these things? There's a MIDI show control specification. This was one of the early specifications. And this was about how they had a lot of MIDI data on stage, like they were using it to talk to all this hardware. So a lot of people that were using other hardware on stage, like lights and pyrotechnics, like this is a really good protocol, maybe we could use it as well. So MIDI said, well, sure, we'll come out with this show control specification. So you can control lights and pyrotechnics with MIDI. This has sort of been superseded now. There's things like DMX for lights, which is heavily heavily influenced by the original MIDI specifications, but it's better and it's more suited to lights. It wasn't just used for lights and pyrotechnics, though. It was also used for things like fountains, when they do big fountain shows with water. The big fountains outside the Las Vegas casinos are still controlled by MIDI under this specification, which is really interesting. Nowadays, we have something like the MIDI visual control specification. So this is held under the idea that when you go and see a band or a show and you're seeing live music, there's also some sort of visual show behind it as well. And so the people doing the visual show were like, well, we've got all this data coming out from these instruments. Can we use that to track the sort of audio and then use that to control the visuals? This is actually one of my favorite specifications. I noticed that some of you went to the bottom link already because you've already connected to me. If you go to that final bottom link, you should get your own little instrument to control, which is actually just a logo, but bear with me, artistic license. Are we good going with that? So this is all you lot playing with your logo. So if you move your logo around, it's going to change on this screen. And I don't know whether you've noticed it's sort of lighting up and flashing. That's because I'm tracking the audio from my microphone. Please don't break on me. It's getting a little bit jerky. And if I play some music, I'm going to do this quickly before it... Oh, request animation frame. He loves it. It should pick up on that sound from my microphone. Oh, performance. Okay. It was always going to be one demo. It's trying. Bless it. Too much going on. But the idea behind this one was you can pick up on the sound as well using the audio API, and you can pick it up from the microphone, and then you can make all those things flash, as well as you controlling all your different bits of it. And this is all using web technologies, which kind of slightly mirrors those MIDI specifications, which I find is very, very interesting. You can find influence in the most interesting things. This is all really, really fun. Like, all these demos are kind of crazy and out there, and that's great things to build. But what about practical uses with things like MIDI and MIDI controllers? We all kind of sit and build websites and web apps, and it seems an odd thing that you'd build a website where you'd plug in a MIDI controller and people might do that. Funnily enough, somebody did, and more people are actually doing this. There are more examples of this. This is Madion's Adventure Machine. This is built by my friends at We Make Awesome. Madion's a French artist, and he had an album launch. So they built sort of a simulated step sequencer, a bit like the one we had earlier, but it was better. And if you didn't have a MIDI controller, it didn't matter, because you could just use your mouse and you could create sounds and samples within it. But if you had a launch pad, like we showed earlier, you could plug it in, and you could use that to interact with the website and use the samples. It was really, really good fun, and they had 3,000 launch pads plugged into this website. That's no mean feat. That's not just one or two people. People have this hardware, and they're really, really interested in it. Navigating web pages. When we talk about accessibility and not being able to use a mouse, we talk about using your device's keyboard, which is fine. We've been doing that for years. But keyboards they're a little bit fuddly. I mean, the buttons on this are much larger, much easier to press. And not only that, but a lot of MIDI controllers, a lot of MIDI controllers have dials and sliders as well. They might be an easier way to get around. Dinosaurs. I know I wasn't going to talk to you about fun things. There's a theme park in the south of the UK where they have huge dinosaurs. And inside these dinosaurs are metal skeletons that you can move around. They're all powered by Raspberry Pis. And we all know that we can run Node on Raspberry Pis. So my friend actually hacks these dinosaurs and makes them move around. And we were in discussions. He wanted to know how to make them more interactive. So doing things like putting a motion sensor on the T-Rex so that when you walked past it, it could turn around and glare at you. And I was thinking maybe with some of the smaller dinosaurs, you could just hook up one of these MIDI controllers, and then you could actually control these dinosaurs yourself. Like, everybody likes pressing buttons and turning dials, right? Controlling your home. All of our homes are hooked up to the web these days. Our lights, our heaters, our fridges, our talking, walking Hoover. This is a desktop drum machine. There's no onboard sound again. It is just a controller. You would put the sound on with whatever software you had on your computer. But you could hook one of these up to your wall, and you could play disco lights. You could hook them up to your lights and just send data. I think that's a really fun thing to do. You could do what I did, so you could write a piece of software where you could mix visuals and take around a little tiny projector with your visual mixing kit and project it onto the streets of your city, which is what I did last Christmas, and it actually went down very, very well. The kids were super excited about this. You can read all about it at 24ways.org, by the way. So MIDI is a really, really interesting topic, and I don't know whether you noticed, but we were actually talking about specifications quite a lot as well. It's an industry that has brought out new specifications based on the new technology which is coming out, which is actually what we do in the web as well. And when it does come out, people seem a little bit like, do we actually really need that? I mean, does MIDI need a Bluetooth low energy specification when we've already got USB? And funny enough, but they're still making instruments with it, and people are really taking to it. So even though you might think, do we really need a Bluetooth web API? Go and have a look at it, because in 5 years, you might think that actually this is actually useful for something that you're building. I spoke a little bit about MIDI API, a little bit about web recorder, and a little bit about Bluetooth. There are quite a few other new ones coming out as well, which I'm constantly surprised by this, because we've had so much new stuff come out recently, and you think, what else can they possibly think at? There's a web payment API, there's web NFC, near field communication, web sensor APIs. So this is things like a light ambient sensor. I could talk about this all day. I'm not going to, because you will get bored. These are just some that I thought of on the top of my head when I wanted to conclude this talk. It's a really, really interesting industry to be in, much like it is MIDI, as long as we always keep it open and always are talking to each other, and all the browser people are talking to each other. It's a great industry. Thank you very, very much for letting me talk to you about MIDI. It's a kind of crazy subject.
Ruth John.
Thank you.